Okay, guys, this is the first scheduling algorithm, the most simple one called first come first serve scheduling algorithm. Now, as the name suggests, the process which requests for the CPU first is the one that will get the CPU. Okay, if you can imagine, we have four processes here and four processes in the ready queue. Now, what is the ready queue? As we've told earlier, the ready queue contains a queue of all the processes that are ready to be run by the CPU. Now, we know that actually it is not actually the exact process that are there in the ready queue, but it's PCB, process control block. So you can imagine, but just for the sake of our exercise, we'll still name the process P1, P2, P3 and P4, even though this could be very easily called PCB1, PCB2, PCB3 and PCB4. Alright, now so let's imagine we have four processes in the ready queue, each with their own burst time. So let's say process 1 requires 6 milliseconds of the CPU's time, process 2 8 milliseconds and so on. With first come first serve algorithm, the algorithm is very simple. So in this case we have drawn a Gantt chart and we have to we will calculate the average waiting time for this for each process in this scheduling algorithm. So let's start. So like I said, in FCFS no decision needs to be made. The first process here is P1, so it needs 6 seconds. So we draw a Gantt chart like this, progress. These are milliseconds. So let's draw from 0, 1, 2, 3, 4, 5, 6 till here. So this time is occupied by process P1. Now for P2 it requires 8 seconds. So again we count 1, 2, 3, 4, 5, 6, 7, 8. So from 6 seconds till 14 seconds the CPU is occupied by process P2. And similarly P3 requires 7, so 1 2 3 4 5 6 7. So from 14 till 21 the processor is occupied by process P3, and P4 requires 3 milliseconds, sorry, 1 2 3, so 3 milliseconds P4. Now we'll have to calculate the average waiting time. So all we do is, so we write average waiting time. Now the average waiting time will be P1 plus P2 plus P3 plus P4 by 4, since there are 4 of them, meaning we will add the waiting time of P1, the waiting time of P2, the waiting time of P3 and the waiting time of P4. Okay, what do we mean by waiting time? So let's check here. So P1, how long the P1 had to wait before it got the CPU. In this case, P1 started from 0. So meaning P1 did not have to wait a millisecond or did not have to wait at all for it to get execution of the CPU. P2 in this case had to wait 6 seconds or until P1 finishes execution for it to get the CPU. So its waiting time is 6. P3 had to wait 14 seconds. It is not until 14 seconds that P3 got to execute. So we will write 14. And similarly, P4 had to wait 21 seconds in order for it to get the CPU. So you can see that P4 had to wait for P1, P2 and P3 to finish executing so that it can get the CPU. Now if we add all this up I think this will be 14 plus 6, this will be 20. 20 plus 21 will be 41 by 4. So it will be something like 10 point something. Let's say some number here. 41, 4, 4 ones are 4, 0, and then put a point, 2, 8, 2, 0, 5. So 10.25. So this is in terms of millisecond. So let's write down milliseconds. So the average reading time of P1, P2, P3 and P4 using this algorithm is 10.25 milliseconds.